This is section 5.2, and it is about the least common multiples, least common denominators, and the addition and subtraction of rational expressions. And so here are the three objectives: to find the LCM, the least common multiple of several algebraic expressions by factoring, then to add and subtract the rational expressions, and then to simplify combined additions and subtractions of rational expressions. And as I mentioned before, rational expressions are a lot like rational numbers, and when we add rational numbers like fractions, when the denominators are different, then we first find the common denominator. So let's review the procedure to find a common denominator. And really the objective is not just to find the common denominator, we want to find the least common denominator. And so let's look at an example. 5 divided by 42 plus 7 divided by 12. So what we do is we factor the denominators, and so 42 factors into 2 times 3 times 7, and 12 factors into 2 times 2 times 3. So the least common multiple would be, in other words, the number to which you can divide 42 and 12 would be 2 times 2, 2 times 2 times 3 times 7. And that is equal to 84. So 42 factors into 2 times 3 times 7, 12 factors into 2 times 2 times 3, and then the least common multiple is the highest number of repetition of 2, 3, and 7, and so we have 2 times 2, 1 times the 3, and 1 times the 7, and their product is 84, and so we know we can divide 42 into 84, and of course 12 into 84 as well. So that would be the least common denominator. When we look at exercise number 3, again we factor the denominators. 12 would be 2 times 2 times 3, and 30 factors into 2 times 3 times 5. So then the LCD, or the least common denominator, would be 2 times 2, because 2 occurs as a factor twice, times 3, the highest occurrence of the factor is 3, and then times 5, and that would be equal to 60. So the LCD is 60, so we add these two fractions. We need to make the denominator equal to 60. So 5 divided by 12. So we need to multiply the denominator by 5 to get a 60. 5 times 12 is 60. But we also need to multiply the numerator by 5 as well. And then we have 11/30. And we need to multiply the denominator by 2 to make it a 60. And so we need to multiply it by 2 in the numerator as well. So that means we now have 5 times 5 is 25/60, plus 2 times 11 is 22/60, and then that is equal to 25 plus 22 divided by 60, or finally 47 divided by 60, and that is irreducible because 47 is a prime number. So the answer is 47 divided by 60. We apply the same method when we have more than two fractions. So here we factor 12, and 12 is equal to 2 times 2 times 3, and 18 is equal to 2 times 3 times 3, and 24 can be factored into 2 times 2 times 2 times 3. So then the least common denominator would be equal to 2 times 2 times 2, the highest number of factors of 2, and then times 3, because 3 occurs twice, and that covers everything, and so that is equal to 72. So that's our least common denominator. And so now when we have 7 divided by 12, we need to multiply 12 by 6 to make it 72. So we multiply numerator and denominator by 6. And then we have 13 divided by 18. And we need to multiply 18 by 4 in the denominator and numerator. And then we have 1 divided by 24. And we need to multiply 24 by 3 to make it a 72. So we multiply by 3 divided by 3. So 7 times 6 is 42 over 72. And 4 times 30 is 52 divided by 72. And then 1 times 3 is 3 divided by 72. And that is equal to 94, and 3 is 97 divided by 72. So 97 divided by 72. Now you notice that this is an improper fraction, where the numerator is greater than the denominator, and we typically leave it that way, unless it is in a word problem or application problem where 97 divided by 72 may not make much sense. Like if there was a number of hours, we certainly make that a mixed number, mixed fraction, or even an integer and a decimal, whatever is appropriate. But for these type of exercises, we leave it as an improper fraction. To find the LCM, the least common multiple, we use each factor the greatest number of times that it occurs in any one prime factorization. So, what does that mean? Well, the factor A occurs to the third power, so and 5 is the one time as a factor, so 5a to the third, and B occurs with the factor 2, so that's why it would be 5a to the third b squared. That's our least common multiple. So again, we look for factors, and so here it's only the factor of 1 for the coefficient, so 5 is that factor here, and then the variable a occurs to the third power, that's the highest, greatest power, and the variable b occurs to the second power, and so that would be 5a to the third b squared is the least common multiple. Moving on to the next example. So to find the LCM for the next exercise, we need to write these sums as factors, And so y squared plus 7y plus 12, we can factor that as y plus 3 times y plus 4. The next expression is y plus 4 times y plus 4, y plus 4 squared. And then the third one is simply y plus 4. So y plus 4 to the second power is the highest number of, for the exponents for the expression y plus 4. So it's y plus 4 times y plus 4. And then we have a y plus 3 as a factor. So that's our least common multiple. And again, the last one, that's already part of the two factors y plus 4 here. So here the LCM is y plus 3 times y plus 4 times y plus 4. When we look at number 7, we can factor x squared minus 9. That's the difference of two squares into x plus 3 times x minus 3. And the second expression, x to the third minus x squared minus 6x, we know that we can factor out an x. And then we have an x minus 3 times x plus 2. And you can learn, you know how to factor trinomials. We practice a lot of times, so it's an application. And then here we have 2 times x times x. So when we look at these various factors, we find we have an x plus 3, and that's one factor only, x plus 3. Then we have an x minus 3, that's already there, so we just need a one time x minus 3. And then there's an x plus 2. And then there's 2 times x, or 2x squared. So that would be our least common multiple. So 2x squared times x plus 3 times x minus 3 times x plus 2. Again, the order of the factors is irrelevant because multiplication is commutative, so the order is not that important. And let's look at number 8. So number 8, we can factor a squared minus b squared as a plus b times a minus b, the difference of two squares. And here we have a couple of options. We can factor out a 2, or we can factor out a minus 2 to make it a minus 2 times a minus b. So then the LCM, the least common multiple, would be minus 2 times a plus b times a minus b. Again, except for the order of the factors, or we can write it as 2 times a plus b times b minus a. These two expressions are equivalent. So minus 2 times a plus b times a minus b, or 2 times a plus b times b minus a. So these are the LCMs, the least common multiples. And we're going to use this method for adding and subtracting rational expressions. So let's begin with a very simple example for addition and subtraction of rational expressions. So we begin where we have like denominators. So in other words, that would be equal to 5 plus y, 5 plus y plus 7, all over the common denominator of y. And then we combine like terms. 5 plus 7 is 12. So 12 plus y divided by y. And that's the answer. And obviously you cannot cancel the y in the denominator against the y in the numerator, because the y in the numerator is part of a sum. So that's why this is the way it stays the way it is. Okay, and for the next rational expression, it's quite the same, because the denominator is the same. So we can simply add the numerators. So when we do this, here's what we'll get. So adding the numerators is like adding two polynomials, because each numerator is a polynomial. So it would be 2x squared, that's for number 10, 2x squared plus 5x minus 9 plus the other polynomial x squared minus 19x plus 4, all divided by x minus 5, because the denominators are the same. We can divide it all in one fraction line. And so when we combine the like terms in the numerator, then we get the following. 2x squared plus x squared is 3x squared. So 2x squared and x squared is 3x squared. And 5x minus 19x is minus 14x. And minus 9 plus 4 is minus 5, divided by x minus 5. What we've done here is we added the numerators, the two polynomials in the numerator, and there was 3x squared minus 14x minus 5 divided by x minus 5. But we can actually factor the numerator, and when we factor this trinomial, using any method you want, it becomes 3x plus 1 times x minus 5 divided by x minus 5. So we can cancel the factors x minus 5, and so then finally our answer is 3x plus 1. So that's the answer to this exercise, 3x plus 1. So you may go over these steps yourself and make sure you can follow them. It's not all that difficult, especially again when the denominators are the same. The next few exercises are about subtracting rational expressions with the same denominator. And again, since the denominator is the same, we can simply write everything on one fraction line. So it is a minus b divided by b plus 2. And that is the final answer, because each one of the polynomials in the numerator and denominator are prime. And again, we cannot cancel the b against the minus b because they're terms of a sum. So when it comes to working with rational expression with the same denominator is really very easy. We write a minus b on the fraction bar in the numerator and then leave the denominator the way it is, and then in this case that is the final answer. Let's do number 12. So again, the denominators are the same, and I'm going to do that in 2 steps for a particular reason. So we have 4y plus 7 minus 3y minus 5 divided by x squared plus y squared. And so what's important to realize is that here we have an expression in parentheses that's preceded by minus sign. So we have 4y plus 7, 4y plus 7, but now we have minus 3y, and we have a plus 5. Again, divided by x squared plus y squared. So then we have, for the next one, we combine the terms in the numerator. And so 4y minus 3y is y, and 7 plus 5 is 12, divided by x squared plus y squared. And the reason we know we can leave it this way is because we know that x squared plus y squared is prime. The sum of 2 squares cannot be factored. And so that then is our final answer to exercise number 12. So that's y plus 12 divided by x squared plus y squared. And just a word of caution, whenever you subtract a rational expression, especially when there's a minus sign there, really be careful how you do that. That is a minus that changes the signs of each of the terms inside the parentheses. So here's the final answer for number 12, y plus 12 divided by x squared plus y squared. Next, we'll be covering the addition and subtraction of rational expressions with different denominators. So to add and subtract rational expressions with different denominators, it's a 4-step process. You find the LCM, the least common multiple of the denominators. This is the least common denominator also. And then for each rational expression, find an equivalent expression with the LCD. To do so, multiply by 1 using an expression for 1 made up of the factors of the LCD that are missing from the original denominator, and then add or subtract the numerators and write the result over the least common denominator, and then simplify if possible. And the last step is pretty important, as we saw from the previous example. So let's begin with some simple guided expression here. So here we have the rational expression 3x divided by 7 plus 4y divided by 3x. So as you can see, the denominators are different. So obviously the least common denominator would be 7 times 3 times x. And so we multiply the first expression by 3x in the denominator and also in the numerator. So that's where this comes from, multiply by 1. Multiply by 1, because 3x divided by 3x is equal to 1. And similar, in the second expression, we need to multiply by 7 divided by 7, which of course is also equal to 1. And so then we get 3x times 3x, that is 9x squared, divided by 7 times 3x is 21x. And for the second expression, we have 4y times 7, that would be 28y, divided by 21x. And so then finally we have 9x squared divided by 21x. And there's nothing to simplify here in this case. And so that is the final answer for number 13. So I hope this process was easy enough and simple enough to understand. And so we look at something a little bit more complex in just a moment here. In the next exercise, number 14, the denominators are x squared minus y squared and x plus y. So when we factor the first denominator, that is the difference of two squares, that is x plus y times x minus y. And for the second one, we have x plus y. So we already had that one, so then the LCM, or the least common denominator in this case, would be x plus y times x minus y. So for the first expression, we already have that, obviously. So when we write the numerator, 2xy minus 2x squared divided by x squared minus y squared, or write with the LCD, x plus y times x minus y. And now we have the second expression, plus 2x plus 3 divided by x plus y. So when we compare the denominators, we notice the missing factor would be x minus y. So we divide by x minus y, and we multiply by x minus y. So again, this expression is equal to 1. So nothing has changed the expression itself. So now we can write everything on one fraction line. Over the denominator, which is with the LCD, x plus y times x minus y. So here we have 2x minus 2x squared, 2x minus 2x squared, plus, so this is actually in parentheses also, we multiplied 2x plus 3 times x minus y, so it would be 2 times x would be 2x squared, and then 2x times minus y minus 2xy, minus 2xy, and then we have 3x, 3 times x is 3x, plus 3x, and then 3 times minus y is minus 3y. Now we're going to combine like terms. So the 2xy cancels out against the minus 2xy, the minus 2xy cancels out against 2x squared against the positive 2x squared. And so we have 3x minus 3y, 3x minus 3y, divided by our common denominator, x plus y times x minus y. And so in the numerator, we can factor out a 3. So we get 3 times x minus y divided by x plus y times x minus y. And now we can cancel the factor x minus y. And so the final answer is equal to 3 divided by x plus y. So that's the answer to the exercise number 14. It's equal to 3 divided by x plus y. And again, one way to find out if that's really correct, what you did here, is you substitute some numbers for x and y, like 2 and 3 or something like that, and make sure that these two expressions are equivalent. For number 15, I'm sure you can see that the LCD would be the product of a plus 3 times a. So therefore, rewriting these expressions, a divided by a plus 3, compare that with the LCD, we know we need to multiply the numerator and denominator by a divided by a, in other words by 1. And then we have minus a minus 4 divided by a, by a. And so here the missing factor is a plus 3. So we need to multiply the numerator and denominator by 1, in this case by a plus 3 times a plus 3 in the numerator. And now the denominators are the same, and we can write the whole expression on the denominator, above the denominator. Our denominator is a times a plus 3. And the numerator, we have a times a would be a squared minus a minus 4 times a plus 3. You better do that in 2 steps. So that's equal to so it would be minus, so a times a is a squared to the minus sign is minus a squared, and 3a minus 4a is minus a with a minus sign gives me a plus a, and the minus 4 times 3 is a minus 12, but with a minus sign there would be a 12. So then what we have left, since the a squares cancel out, we have a plus 12. A plus 12 divided by a times a plus 3. So that is the final answer for number 15. So let's write it down next to the problem statement. Equals a plus 12 divided by a times a plus 3. There. So here you have the derivation of the answer, and I hope that will help you understand how we add and subtract rational expressions with unlike denominators. We do a few more exercises to get the hang of it. And so the important thing is that you practice this yourself. It requires a fairly high level of concentration and attention to detail. But again, that is just some of the basic necessities in math. So what we need to do, number 16, we need to factor the denominators. And so that means we're factoring the first denominator as y minus 3 times y minus 4, and the second one is y plus 5 times y minus 3. So then our LCD would be y minus 3 times y minus 4 times y minus 5, because we already have a y minus 3 here. So the LCD is y minus 3 times y minus 4 times y plus 5. So that's our LCD. Okay, so then when we look at the first expression for y minus 5, and we write the denominator in factored form, and as well for the second expression, we get the following. So we have in the numerator 4y minus 5. In the denominator we have y minus 3 times y minus 4. And when we compare that expression in the denominator here with the LCD, we notice that the missing factor is y plus 5. So we need to multiply by 1, in this case y plus 5 in the denominator, and then y plus 5 in the numerator. Similarly, now we have minus, and here we have y plus 7. And when we write the denominator in factored form, it is y plus 5 times y minus 3. And again, comparing the denominator with the LCD, we notice that the missing factor is the y minus 4 rather. So we multiply by 1, in this case y minus 4, y minus 4, that's equal to 1, this factor here. And so now we have a common denominator, and now all we need to do is multiply out the numerators and subtract. And when we do that, we get the following. We get 4y squared plus 15y minus 25 minus, now we multiply these two expressions, y squared plus 3y minus 28 divided by the LCD, y minus 3 times y minus 4 times y plus 5. And again, I'm doing this in 2 steps to make sure that we subtract all the terms in this, or that we subtract the second polynomial. Otherwise, it's too easy to make mistakes. And by doing this correctly, we get the following. So we have 4y squared plus 15y minus 25 minus y squared minus 3y plus 28. So combining like terms in the numerator, 4y squared minus y squared is 3y squared. And 15y minus 3y is 12y. And then minus 25 plus 28 is plus 3. And so then the only thing we can do in the numerator, we can factor out a 3. So by factoring out a 3 in the numerator, we get the final answer, 3 times y squared plus 4y plus 1 divided by y minus 3 times y minus 4 times y plus 5. So that is our final answer to exercise number 16. So we're going to write that down. So this is equal to 3 times y squared plus 4y plus 1 all divided by y minus 3 times y minus 4 times y plus 5. So number 17 is pretty simple and straightforward because it's b divided by 3b. And then plus b to the third divided by minus 3b is simply minus b to the third divided by 3b. And we can write this all in one fraction bar now as b minus b to the third divided by 3b. In the numerator, we can factor out a b, which gives us a 1 minus b to the second power divided by 3b. Now we can cancel the b's. And 1 minus b squared is the same as 1 squared minus b squared, so we can factor that into 1 plus b times 1 minus b divided by 3. So this is a difference of 2 squares. 1 is the same as 1 squared, so 1 squared minus b squared factors into 1 plus b times 1 minus b. So that is our final answer. So that's equal to 1 plus b times 1 minus b divided by 3. Number 18 is very similar. When we look at the denominators, the second denominator we can write as 5 minus x is the same as minus 1 times x minus 5. So then the first expression, of course, is the same. 3x squared plus 4 divided by x minus 5. And the second expression becomes then x squared minus 7 divided by minus 1 times x minus 5. So that is then equivalent to 3x squared plus 4 divided by x minus 5 minus x squared minus 7 divided by x minus 5. And so now we have the same denominator. We simply subtract the numerators. And so 3x squared minus x squared is 2x squared. 2x squared. And 4 minus 7 is 4 plus 7, that's 11. Plus 11 divided by x minus 5. So that's the answer for number 18. So it's equal to 2x squared plus 11 divided by x minus 5. Number 9 is somewhat similar in that we have 3 divided by 4y, and the minus y becomes a plus 7x divided by 4y. And now we can write all this on one fraction line. 3 plus 7x divided by 4y. And that is our final answer for number 19. So that's equal to 3 plus 7x divided by 4y. So some of these exercises are simpler, others are more complex. So you have to be able to deal with both types of exercises here. When we look at number 20, the guided solution, we look at 4x squared divided by 2x minus y minus 7x squared divided by y minus 2x. So we notice that the denominators differ by a factor of minus 1. Therefore, we leave the first expression the way it is, 4x squared divided by 2x minus y, minus, and we multiply the second expression by minus 1 in the denominator and the numerator. And so then that becomes a, well, again, the first expression remains the same, 4x squared divided by 2x minus y, minus, and then minus 1 times 7x squared is minus 7x squared, divided by 2x minus y. Because minus 1 times 2x is positive 2x, and minus 1 times y is minus y. So then we have, here we have 4x squared minus 7x squared divided by 2x minus y. And so we have 4x squared, and the minus is a plus, and 4 plus 11, and 4 plus 7 is 11x squared. So 4x squared plus 7x squared is 11x squared, which is the final answer to exercise number 20. This concludes section 5.2.